Now that we have seen how to access individual numbers in two-dimensional array, say we wanted to do more than that, like calculate the average grades that all the students have achieved in English. This means we need to go through each and every student grade in a particular row. Remember that a two-dimensional array is basically an array of arrays. So each row here is an array by itself. So if we wanted to access every single item in a particular row, we specify the first number to be the index of that array, but the second index, however, we don't want to specify items, we want all of them. So we can surround this with a loop that uses index as a counter, which starts from 0 and as long as index is less than 5. And then we can actually use this loop counter as our index here. Now this loop counter index would have all the values from 0 to 5, while 1 is specifically for the English row, which means once we run this loop, we are accessing every student in English row. So our loop would go through every item in this particular row. Let's see how we can use this to calculate the average in a Java function. English average is a function that calculates the average of a two-dimensional array. It takes in this two-dimensional array of integer as an input parameter and returns a double value which is equal to the average of all the items in that two-dimensional array. This loop here is the one that we have just created earlier. It starts with the loop counter index equal to 0 and keeps going as long as index is less than 5. And inside we are accessing the grades of 1 and index. Remember that grades of 1 and index accesses every single student in a row of English. So this loop here would go through all the students in the English array. Now what we want to do is add up all of these inside this English array. So we can do that by declaring a total variable at the top and add this value to the total variable every single time in a loop. By the end of this loop, total would have the sum of all the values and grades, and then we can start calculating the average by dividing that with the total number of items in the array. Once we have calculated the average, we could safely return it as the result of the function. Notice that I have divided this by 5.0, not just 5, because total was declared as an integer, and if I want the result of division to become double, that's perfect. Now let's see what we need to do if we wanted to calculate the average of a column, like finding the average grade of Sandra. To calculate the average grade of Sandra means we need to go through every item in a particular column. This would be very similar to what we have done with the English array, except that now we want to go through every subject array, not just the one, which means our first index here has to be the loop counter index, while the second number here would be equal to the index of the person who I'm interested in. In the case of Sandra, that would become 2. Now this means that this loop would go through all the grades that Sandra has achieved in all the subjects. Let's see how we can use that in the Java code. The function SandraAverage takes in a two-dimensional array as the input and calculates the average and returns it as a double. It starts by declaring this total variable and initialize it to 0, and then it loops over all the grades under the Sandra column. This is done by using the loop counter index as the first index and the number 2 for Sandra as the second index. And again, inside the loop, we are just adding grades to our total every single time. So by the end of this loop, we could just divide our total value by 4, which is the number of subjects to get the average grades that Sandra have achieved, and then we can return that. This looks pretty good. However, there are a few things that we can change in this function to make it more readable and easier to understand. First of all, these number 4 and 2 and 4.0 don't really mean much to someone who hasn't seen the array before, especially if they don't know what the array has inside it. So to make the function more generic, we can actually figure out those numbers inside the code itself. Like 4, which is equal to the number of subjects, can be deduced from the two-dimensional array that's passed in as a parameter. We can do that in the very first line of our function by using the keyword length again. Remember that when we use the length keyword, we are counting the number of elements or item in that array. And since grades is an array of arrays, grade.length tells us how many arrays there are in this two-dimensional array, which is equal to the number of subjects. So we can store that in a variable called subjects and now replace any 4 with that variable instead. And when we get to the 4.0 down here, because we want to make sure that our subject is a double, even though it's declared as an integer, we can cast it to the double row like we have learned before. So the average is now calculated by dividing total with the number of subject, but cast it into a double. This looks much better now, because this would work for any two-dimensional array, no matter how many subjects are inside it. One last thing we can do here is to generalize this too instead of having a function specifically for Sandra. And instead of having a function that calculates the average for any student that we specify, the best way to do that is to have a generic function called studentAverage that now has an extra input parameter, which is an integer student. So it takes in the actual two-dimensional array with all the grades in it and the student index whom we are interested in calculating the average for. So inside we could just replace the square brackets here with this variable student, which means whatever number we pass in as an input parameter would be used to access this grades two-dimensional array. Now our studentAverage function would work for any student we specify and with any two-dimensional array that has number of subjects in it. So what if we wanted to do more analysis on this two-dimensional array? Say we needed to loop over the entire array, accessing every single number in it. It almost seems like we need a loop for every row, and inside that loop we need to go through every item in that row. A loop of loops. Yes, that's actually possible. Just like nested if, we can actually have nested loops as well. Let's see how.